exactly for this. Spark can give the developer the opportunity to work with data, and sometimes you even won't know that the data is across the cluster. So you will work with data like your local collection of data, with the same functions like map, flat map, Java 8, or if you have Scala, you will work with Spark. It will be native for you, because almost the same API you will have in Spark. So the main idea of Spark is to process the data all over the cluster. So, and this processing is the batch mode. So we have a big amount of data all over the cluster. We are running our Spark job, and we are getting the result in HDFS, maybe in Kafka, and our target can be different. So what if we need to process the data in real time? So we don't want to process the data like batch mode. We have hundreds of data. So we want to process the data in real time. So we don't want to run big amount of data and something. We want to run real time. Spark streaming exactly for this. So Spark streaming is an opportunity to process data in real time. Spark streaming can consume data from different data like Kafka cluster, Zoom, HDFS, Amazon Active Storage, Amazon Kinesis, and you have a lot of different receivers to get data from Twitter, from local file system, from network socket. So we will have a lot of examples, almost like all training. We will write some code because there is nothing a lot to talk about the Spark streaming. So Spark streaming will work all over the cluster. The main goal of Spark streaming is to prepare data for your Spark engine. So how we can do it? In general Spark engine, RDD. You can think about RDD as a distributed collection of data. So you can think about general collection from your language, but this collection RDD is resilient data set. That means that this collection all over the cluster. Even if you're one of your fields can work with that. So the goal of Spark streaming, you have the stream of data. Spark streaming will chop your data on pieces. Will make batches, and finally you will have the regular RDD to process in Spark engine. So the goal of Spark streaming is to prepare data for the Spark. So if you're familiar with Spark and you work with it, for you, this part you know. RDD is distributed data. It's a main abstraction in Spark, and you can think about it like a general collection from your language. This is the collection of data, but distributed. And all your methods you will apply to this collection, we will execute all over the cluster. You can complete. So we will talk about this part. Of course, all our examples will Spark engine. What is the main API to use Spark streaming? In Spark, the main abstraction is RDD, Resilient Distributed Data Set. In Spark streaming, you have different abstractions, discrete type, streaming. Under the hood of this abstraction, you have ordinary RDD. That means that when you're getting this type of object, you can use the same functionality as in general array. So you can use map, let map, filter. Of course, there is a difference because sometimes you need to work directly with RTD, but we will see a small example about this. But general transformation all over the map and functions, you have the same API in this stream. So, for example, okay, so is it structured? What do you mean structured? No, there is no structure. You can apply methods to sort your data, but it's like general collection. You don't have order, so it's not a list. Schema. In RDD, no. If you want to apply schema to your data, there is a upper layer of abstraction. You have in general Spark engine. You have data sets from new Spark version, and you have data frames from.
Stream doesn't work with it.
Data frames.
Stream doesn't work with it.
Stream.
Does it work with
you mean that in Spark streaming you have abstraction data. So you have to work with, you have only the stream abstraction. Under the hood, if you, for example, finally in your processing of data, you need to insert data to Kafka queue. For example, of course, you will need to use RTT API because we don't have an opportunity to insert data to Kafka directly from this type of data. So we need to go through every RTT and data stream and use the inserting data to Kafka under the hood of this. So let's write first example. We know that the main abstraction, but I know that a lot of people are not familiar with Spark, so I will try to. Ever use Spark application? Somebody. Your main point when you're starting writing your Spark application, the main point is Spark driver. Spark driver, so every time you're starting to write your Spark code with Spark on object. This is the entry point to your Spark application. So we need to set several parameters like set master. We are going to run all our Spark examples locally. So my parameter means that I'm going to, for mistake I wrote this. That means we are going to start run on my local PC, and I need to set up like application name for this. What is our example? We are going to listen the network socket for the text data, and it will be the simple example. I want to count the words from the socket. It will be the regular network socket, and I'm going to count all the words from so here I am running the server. Here I will put the text data to my Spark streaming process. The next one, entry point for Spark streaming application. Spark, we need to create the streaming context. Streaming context we are creating from the configuration, Spark configuration. And the second parameter is how often we are going to consume data from our source. How often we are going to Spark our chain of processing data. This is the base time interval in Spark streaming, batch interval. My parameter means that I'm going to start my streaming process every second. I'm going to consume data from socket every second and do some job with this data. So,
and question. Okay. What happens in case the batch finish 1 second?
Good question, but of course it depends how much time will take your data. If it's 2 minutes, if you're consuming data, if you have Kafka, you can wait the next day. I mean that your period of processing data will take, you will consume data, but your general Spark engine, you interpret it. And we have the first part, Spark streaming. The next part, the last part is Spark engine. So if Spark engine won't finish to process your data, you will just wait. That means that you, of course, you will need to adapt your properties, your data purpose. Sometimes, but in generally, don't have, if, for example, your batch interval 1 second, how much data you can consume for 1 second? Of course, it depends, but in general, to run your batch, you don't have gig of data to run 1 batch. So, general data intervals like 5 seconds.
Have manipulation to the data and
Take time, yeah, but it depends what you're going to do. If you're going to insert it to Kafka, and something happens, network. Now we have Spark streaming context. This is the from this point we can create receivers for different data sources. So we can create receiver for socket stream, for listener, for file system, different additional receivers from Kafka, Twitter, and so on. So here we are going to listen socket. We are going to create socket receiver. It's called socket text stream. The first parameter is the host name, so we are working local host. My port is I have lines here. You can see that the type now we are working with type of district, different kind of district. So from this point, we are starting to do manipulations with our data. Now we have lines. If it will be the simple example how to count words, but if you're not familiar with functional API, let Matthew ask questions. I will try to explain it fast way. So if we have line general string, we are going to split it by space, right? And to make word count, we are going to make a tuple. What is the tuple in Java? It's like pair object. I will create the tuple, the word, to 1, and after it, I will make the reduce by key. The reduce by key will take all tuples in my current state, right? And do the reduce operation by summarizing the ones. So in general, for example, I have hello string. I will build tuples. I will have two tuples, hello 1 and hello 1. And after reduce by key, I will have one tuple with key hello and with the count of words to. So if you need the explanation of why we are using flat map, here we have the line. We are going to split this line by space. Now we have the words. Again, you can see that the type that we are working with is gestring. If you're familiar with Spark, you know that in Spark we have like the same function. So it will be easy for you to, if you're using Scala, to move from Scala to Spark, or to Java. From Java.
What do you mean
to Spark? Because if you're familiar with Scala, you have almost the same API. So you have the same functions in Spark. And if you're familiar with Spark, you will use the Spark streaming. You have again the same functions. So from words, I'm going to make the construction of tuples. Here I have word, and I want to make word. So now I have tuples of data, and tuples, I'm going to reduce by key, and if you're not familiar with Scala, it's reduce. Here, I put the function of reducing. That means that I'm going to summarize all these values by key. So by word, I'm going to summarize all ones. And this is the word counts, and I am going to print it. Print is very useful function to work with Spark streaming because even if you are using the big data sets, print will print for you like first 10 examples of data, even if you have large collection. So it's like a good way to debug simple part. Now we have the logic of data processing. How to start Spark streaming context. In Spark streaming context, we have starts. From this point, our Spark streaming will listen our socket and put the data to Spark engine, do something with data, and print it on the screen. But one main point that we saw on the here we see that we have two different kind of processes. First one, Spark engine. The main point of Spark engine is Spark driver, the main entry point to Spark. That means that we are going to run the thread of Spark to process the data. And also we need the thread to run the Spark receiver to consume data for TCP socket. This method, Spark streaming start, will run for you the streaming context. That means that you will listen this TCP socket to consume the data. But you need to, that means that our program will finish here on start, and we won't see any data at all. We need to wait that our data, the processing of our data will be finished. So the function await termination will wait until we manually terminate the program. So let's try to run it. I run my netcat. This is the Linux environment. So this is, if somebody is familiar with this, like here the big mistake, but very important, because it's like one of the first mistakes when you're starting using the Spark streaming. If somebody knows, as you can see here on the receiver, we started the receiver of data. That means that now we are consuming data from the socket, but nothing is happening, right? So we can't see any results here. The mistake is that I told about two processes. The first one is Spark engine to process the data. The next one is receiver. Now we have only receiver. The parameter local without parameters means that we are going to run our Spark context only with one thread, with one core processor. But we need two, at least two, because we have two threads. We have first one for Spark engine and next one for receiver. So with parameter 2 or 4, we can set how many cores we are going to use in our Spark configuration. Let's rerun the example.
זה מישהו אחר כאילו.
We are consuming data every second. Here you can see the two. We can run it 5 seconds. Best.
What will happen if you give it more than 2 threads? You won't use more than 2, or we do something far?
You're going to run it on the cluster.
No, but the socket will be open on more than one thread. The socket, listening to port 9999. You need to run it on.
Socket will listen only your receiver. But you have two entry points. So for in Spark you have one entry point, receiver. Receiver will consume your data and put to the Spark.
No matter what, it will do it.
You have one receiver. But after you consume the data, you can spread this data all over the cluster. This is the result. Hello, 2 times. Okay. Any questions about this first example?
Yes. Yeah. You said something about processing a large amount of data, and that you won't do it in Spark streaming, not gigabytes of data, but right? You said that you're not expecting a single frame to be gigabytes of data.
Yeah, of course.
But as far as I know, Spark main concept is to process a large amount of data on large amount of memory. So
I talked about the general Spark engine. The classic batch mode of processing the data in the Spark engine is to consume, but you have like hundreds of giga or several hundreds, and you're processing it in batch mode. So you run it once, take the data, put somewhere, next day run again, take the data, put somewhere. But if you are going to run it on runtime, so for example, you have like devices like Internet of Things, you have a lot of data, different kind of temperatures. So you don't have a lot of data for 1 second, right?
Yeah, but if I'm processing like my customer depends from all over the channels available to have a lot of data. So we can talk about
big cluster for this.
We can talk about optimizing the batch size with the memory and the cores that you get the Spark. And
by default, by default, Spark will put your data twice to the cluster. But optimization to processing data, Spark engine is not Spark streaming. The main goal of Spark streaming: consume the data, split it to RDD, and put this RDD to Spark engine to process. The second part of processing data is the Spark engine. General Spark engine can optimize. You can create how many speakers you want. You can how much memory you need, and it's like general. And it will be general Spark. It's not about Spark streaming. Spark streaming, it's if you are going to consume real-time data, you need to prepare it to Spark engine.
But it is built for large.
Of course, Spark engine.
No, not Spark engine. The Spark streaming. What is the maximum size?
Maximum size of data set?
Of frame of data that is received, let's say for your time frame. Is there a limit? Not to waste.
No, I don't. It's not limited. So if you're running the Spark streaming like every 1 second, okay, you will have like how many data. Giga, maybe several. Okay, so it depends, of course, of your receiver. If you have a class Kafka, or if your receiver is Kafka receiver, and you are connected to big Kafka class, so you can consume big amount of data at one time. But you will spread all the data to your cluster. Configure your cluster to process the data faster.
So if I can process my data in not a batch way, a traditional way, not by streaming, by
traditional way is the batch way.
Okay, so not the traditional, in like a normal job. It's configured properly, then I want to move to batch processing, it will be okay. No memory, no.
It depends how you will configure your Spark. I mean the general Spark engine. Because when you're submitting your application, you can put the parameters, how many computers, how much memory. So it's like very okay.
Things to be ordered when
ordered.
Something that you mentioned is distorted.
No, it's the question about structured data of work. So in Spark, in RDD, in general collection, regular collection, the main abstraction in Spark, RDD, it's an unstructured collection of data. But you have in Spark, you have API like data frame to make it structured. So is there a meaning to partition? This is the general Spark. Of course, you can create how many partitions you need to have here in your chain of processing data. This is the if you're not familiar with Spark, you can, for example, by default, when you are consuming data from file system, you have like thousands of files. By default, Spark will create, for example, one partition for every file when you're getting data from files. And you want to, of course, to repartition it. So you don't need to have, if you have 100,000 of files, you don't have to have 100,000 partitions because you do a lot of threads. You need to switch into this. First, here you have the same operation. You can use repartition method to repartition. We will use repartition in the example because we need to have the data, the result data in one place. So now we are moving forward, and the next example, more difficult, but in this example we will cover all the Spark streaming opportunities like different count by window, saving state from one batch to other, and this is the example. We will have file, and this is the file format. Now we are building the application like for company like who is selling or buying different stocks, like brokerage firm. Okay. This is and we want to monitor this application. How many buy, how many sell. This is the example. The first one is timestamp of data. In what time of the order. This parameter is order ID. This parameter is client ID. Like if we are counting from 0, it's parameter 0, 1, 2. This is the name of assets, for example. Okay. This is the amount of assets, the price of one, and the type of operation. Is it buy or is it sell? So in this example, we can see that in this time we have an order from client ID 99. The order ID is 1. Type of the SDK, amount of S 15, and price of 1 is 10. And this is the buy. That means that client 99 bought this stuff. This is the description of format.
There's a problem.
What?
Order.
Order?
Order.
I ordered, yeah.
Order is not.
No, it's like.
Order is just what you want.
Yeah, it's ordered, yeah.
בסדר, אני יודע. לא, עכשיו זהו, עושים להכל, אני יודע.
To buy or sell something, okay? And the first step.
אני בסדר. לא יודע, מחכה לי כמה תשובות, מה שנקרא, לא יודע. בזמן, באמת, לא יודע.
So this is the file example. Here, I'm not sure, but in the file we have like several hundred thousands of such orders. The file. How we are going to consume this data? We will use the other receiver of Spark streaming. We will use the file system receiver. But one thing, file receiver will listen your folder. That means that if you already have the files in your folder, they won't be consumed. So after you're running your Spark streaming context, you need to put the data. Your receiver is listening to the folder. So you need to have new files on runtime. So how we are going to do it? We are going to split this big file to small files, and here this is the simple script. We are going to copy this data like with the delay to some target folder. Okay, so this file will be split on several parts. I think like 100 maybe. It's not important. And this is our target folder for the data. We will see result. This is the output orders. It is the folder of results, and input orders we will have here. So let's run. Now the first step is to build the application where we have the base time interval in Spark streaming. It's how often we are going to consume the data. This is the base interval. And the first step is we want to know every second how many bytes or cells were in our application, in our base intervals. In every second we want to know how many were cells, how many were bytes. So let's how we are going to do it. The first line of code will be the same, right? We need to build the Spark configuration, Spark object with the same parameters. We are going to build Spark context from the configuration. Yeah, but here we are going to use the not socket text stream. We want to listen the file text file stream. Here, just one parameter, the place of our folder. Home folder input orders. Step now. Okay, for here we have lines of our data, right? But let's build the main abstraction object for to process with data. So we are going to build like simple class order. That finally we will have collection of these orders. So we are going to create the case class. If you are not familiar with Scala, it's like Java mostly. You can think about case class in Scala like Java POJ object with a lot of getters, setters that will be created by default for you. So if you're Java developers, maybe you are using the Lombok framework, and you can have all these methods by using annotations from Lombok. But in case classes you have a lot of opportunities, but it's not now. So we are going to make case class order. The first parameter will be the timestamp. So it's like timestamp. Right. The second parameter is the order ID. It will belong. The next parameter, client ID. Also. The fourth one is name of person. So string amount. Int, it's a integer from Java, and the price, double, and by boolean. We are going to use this last parameter, like if it's B, we will have true in our field. If it's cell, we will have false. So now we are going to view this collection of these objects. Open this. Map. This is the basic transformation from Spark Engine also. We're going to map our strings to object. One string to object. So we have line here. We are going to transform it to this. We need some date format for our date format. Our date format is right. The year, month, day, time. Let's use this one. On the day, hour. So when you want to create a case class, you don't need to write a U or something like that. So now we have date format. We can parse the first parameter. Parse. Line, it's to the parameter. The next one is just
What's the line? What's the size of the line? Is it a string?
Line of 1 second. Line, we are going to split it first. We are going to split the line by comma. Yeah.
Better to declare the date format outside of the...
Date format? Yeah. I agree. The next one is we have time. Order ID. Like it's params 1 to 1. Params 2 is a client ID. Param 1. The next one is name of the assets, right? Params 3 is general string. We don't need to do anything. The next one is amount. Parameter 4 to integer. And params 5 mount to double. And the last one is a boolean. How we are going to build this boolean? If it is is equals to B. So that means if it's equal to B, we will have true. If it's not, we will have false. We have new times. And yes, we don't have construction stage, so we need to get time from Nesכים to time. Our so the result of this manipulation should be our orders. So if we open the type, again, we have this stream objects of orders. Our first test is what is our batch process. So 5 seconds, we are changing it to 1 because we want to know every second how many we have bytes and how many we have cells. So now we need to prepare our orders to this kind of. So now we have order. Our result should be by or cell, how many? So for example, 2, 100 cell, 200. We are going to build, again, we are going to build a tuple because we don't need the whole order of it. We will take only fields that we need. So we have order here. Again, we are using the map from order. We need to take only the what is it by or cell, and again one where we are building the tuple. After it, reduce by key. None of orders. Again, type. Now we have the history of tuples. The first one is Boolean, what is it, by or cell, and the last one is long, how many bytes. That's all. Now we want just to save this data to file system. Number of orders. One more thing. If you are processing the data all over the cluster, you have results on every node now in your cluster, right? And if you will call the function, for example, save it as text files, you will have small chunk of data all over the cluster on every node. But for example, we don't need. If, for example, we will have 2 executors, I will have several folders. I don't need or several files. I'm going to repartition the data to one partition. So I will have data in one place. That means when I call the function save as text files, it will be executed only on one executor. So as a result, I will have one file of result with all data that I produce.
Can you use coalesce?
Coalesce is not the goal of coalesce is to reduce the amount of partitions. For example, when you are reading the data from file system, you have hundreds of thousands of partitions. You want to reduce the amount of partitions. This is the result.
Not the case.
This is nothing.
So why you need to partition?
You're doing coalesce not as a final method. You're doing coalesce to prepare data for the next session. I know that there are several optimizations of reducing
why you need
the goal of coalesce is not create one partition. The goal of coalesce to optimize reducing repetitions. So,
but why here you need to repetition the data from
now
for one? Yes, because it can stay in the same place.
No, for example, here I can
give
give
to one place, but you don't have to move from one place to another.
Yeah, you mean shuffling. But now, if I have two executors, even on my local machine, I will have two results on two executors. I will have, for example, bias and self on one executor, bias and self on one. When they save them, even in the local files, as a result, every executor will save a file for me. As a result, every executor. That means I will have, if I have.
But if you go, you said if you write coalesce for one, then
I will have one partition.
So it's what you need also.
Yeah, but the main goal of our coalesce is to reduce your big amount of partitions for the next process. I mean that now we need to have just one partition. But coalesce will make for you from thousands partitions, will make, I don't know, hundreds of how many, but it will be, this repartitioning will be optimized for the new amount of partitions. But here we don't need any optimization for it. We need just one partition. That's why I'm using the regular repartition. So now I want to have all my data on one executor, and I go into all save as text files. And again, my result is order south. Oh. That's all.
Where is the shuffling? In which place is the action to collect the data from one place?
This is the collection data of one place. This is the repartition. Now we have data on one executor, but generally we are running our application with two cores. Yeah. One for streaming and one for processing.
No, I'm just talking in general.
In general, we will have one partition. And we have one executor.
No, not for this. If you are running on cluster, so.
But when you're using the cluster, of course, with Spark streaming. Generally, maybe you're not going to save data to your files, right? I think you want to put it to Kafka, for example, for the next maybe HDFS. Maybe HDFS, but you need to know that if you will have 5,000 of partitions and your result will be small files, it's not a good idea to save a lot of small files to HDFS. Maybe you will do repartitioning to process that. So, like, in Spark streaming, your result will be small amount of data. There will be a lot of small files, right? Mm-hmm. You're not going to save a lot of small files. So maybe later you will need to combine them to big file. But let's run it. So the first one we need to run let's run the Spark streaming. Here we have the result folders. Folders. No? Okay. I have a new word. Let's run again. This.
Don't use the refactor or not project.
Yeah, but I can't remember.
Right? There are exceptions to the law. Let's see.
No? To rerun the virtual. Pause. So the result of this, we'll see it later, the result of this data processing, we will have one file, and in the file we can see how many bytes, how many cells for 1 second. So then each second you have new data. So for 1 second, how many bytes, how many cells you have every second. The next test is we want to know about our top 5 clients. Top 5 clients. What is?
Yeah, I understood. Each second saves a line to the file, or you save a file?
Each second, I'm saving the file. Saving the file.
You're adding a line, appending a line to the file, and saving.
No, not that. We have a new file. Oh. Every batch interval, every second, we have new files with the data of 1 second.
It's not aggregated data.
It's not aggregated. It's new piece of data for every batch interval. So every file will contain the data for 1 second. So we counted how many bytes, how many cells we have for 1 second of time. I'm consuming file from the folder every second, right? Like some piece of data.
Okay.
Counting how many bytes and cells we have and save to the file system. So we will see the result. But the next step, we want to know on runtime. Now we don't want to know what is the top 5 clients every second. We want to know who are top 5 all over the hour process. That means that on runtime, the top 5 will change. It depends on orders. So for this test, we need from Spark streaming to update the state from the previous run. That means that we counted the top 5 sellers or top 5 clients from the previous run, but we need to put this data to the next run, to the next stage of Spark streaming, to the next batch interval. Spark streaming has such API for you. It will work like this. You have a data every batch interval. You have a stream abstraction, and the result of every batch is some state. The next update state, we can use the information from the previous running of Spark. So we can move all over our Spark streaming context, and we can count top 5 clients all over our Spark streaming process. Spark for this test, Spark streaming API has the function update state. So how we're going to solve it? We need the top 5 clients. Client ID is here, right? So we are going to build the same structure. Tuple client ID to how much money was spent, got or spent. That means we don't know. We don't want to know what is the top 5 buyers or sellers. We want to know top 5 clients at all. That we don't care about this sell or buy. We're going to multiply the number of assets to the price. So we are going to build the tuple client ID versus this multiplication of these parameters. Okay? And we are going to update state for every client through all over our Spark streaming process. So that means that we will summarize the previous amount for this client. We are going to summarize with the amount of money of next client. Intelligent. Example. So the first stage is the same. So we are building we have the orders collection here. This is the first test that we build the amount of cells or bytes. And now we are going to, and this is the test suite. We are building the tuple, client ID versus amount of money. The amount of assets multiply price. This collection of data is the stream of tuples. Now we are going to save this state through the whole Spark streaming process. We have for this the update state by key. The parameter, the first parameter of this function is the tuple, the first parameter. So we have a lot of tuples. For example, client ID 1 to some amount of money. Update by state by key, it's kind of reduced by key. That means that finally we will have collections of all amounts of money for this client of 1 second. We are running every 1 second, every batch interval. For example, we have a lot of execution. Here, this collection, this sequence, it's a list of all amounts for this client. This is the collection that reduced by E already for you. That means it's client 1. Of one executor, you have tuple, client ID 1 to 5. On second executor, you have client ID 1 to 5. Here, you will have the sequence of all these amounts. Right? Okay, is it information? Update state by key. It's or is it it's it is now you are updating state in your Spark streaming machine. So it's not like it. I think according to Spark, it's an action because you will update the state exactly right now. But it's not. I think to think about it like transformation for action, it's not correct because when you are processing data, you want to know if it is a lazy operation or it's not, right? Or update state by key, it is something internal in Spark streaming. You need to know that after this function, you will update the state internally in Spark streaming. So it's not like it will be done, of course, just now, but it's not the state of specific entity, right? To update the state for not specific entity, to update the state. It's not updating RDT. We are not talking state. So what will be the state in Spark streaming? To make the state, firstly you need you can see here to work with different state methods, or you can update state by key, or you can update something in the big interval, in a single interval. You need to set up the folders, the checkpoint folder for the Spark streaming. This is the place where Spark streaming will put its state. So it's internal data of Spark. It's not your data. It is the target for the middle data of Spark streaming. Spark streaming needs to save it somewhere, your middle state. So if you are going to use the different update by state methods of Spark streaming, you need to set up the checkpoint folder. If we run this example without setting up the checkpoint folder, we will get an exception. So or using update state by key, you need to set up something like to set up the checkpoint folder. And update state by key. This is the all new values of this batch interval, and this is the previous state. Why option? Because if we are running the first time, we will get none because we don't have the previous state. If we are running the next stage, we will get some of the previous state. How we are going to summarize it? So if you are not familiar with pattern matching, it's like super switch from Java. So you can match everything. So here we are matching the type of our object. If it is sum, we are going to create sum of new values plus the previous total. If it is the first run, so none. We don't have the previous state. This is the first batch interval. We are going to produce sum of our current values from the current batch interval. And one more thing, we want to save this data together in one file. So we want to have how many bytes, how many cells, and in the same file we want to have the top 5 clients. And who are the top 5 clients? I mean IDs. We will have two different. Now we have two different types. The streams. The first one is number type, the bytes and cells, and the next one is amount state. So we need to prepare the. Okay. We need to union these two streams. To make union of two disk streams, we need to have two disk streams of the same type. So if you have, for example, this stream of string and this stream of long, you can't union them. You need to have this stream of the same type. So one of the steps we need to do is to prepare our disk streams to make it the same type. So the first stage, top 5 clients. We don't need to know. Now we are updating state of all of Spark streaming stores for us information all over the client, but we need to save to the result file only top 5. How we are going to make it? Transform method of this stream. Here we have the result, also the stream, but to calculate the top 5, we need to sort our data by amount of money for every client, and then take the top 5. We don't have sorting in this stream API, so this is one of the differences. That means that we need to get the RDD from this stream and make sorting in RDD. So transformation. Is a transformation. Here you can see the parameter of transformation is RDD. When we are calling transform from this stream, here we are getting the RDD. Now we can work with RDDs which are under the hood of our disk stream. That means that we can sort this collection. Again, that means, remember, we have tuples of two parameters. First long is client ID, the next long is amount of money. We are going to sort by amount of money. So this is the second part of tuple, and we are going to sort it in descending order. After sorting, we need only client IDs. So we are using the map. We are taking only client IDs. We don't need the amount of money. We need to know only who are the clients. We don't need how much money to know. And now we have the RDD of only client ID sorting by amount of money in descending order. But we need only top 5. How to take top 5? We are going to put the number to every tab. So that means to every client. We have the zip with index. It's a making tuple. And we can do like auto increment like in SQL database. We are doing something like auto increment. That means that we will have a unique ID for every client ID. So now we have a collection of client ID that are sorted by amount of money in descending order. And we want to index this collection. That means that we are going that in the top of our collection we have like top clients, and we will have like first client, which like bought more. We will have 0, 1, 2, 3, and we have up auto increment. After this one, we want to cut all the collection with only first 5 clients. So we will have only top 5 clients ID from the source collection of data.
Shouldn't we filter it first? Filter. Yeah. Before the zip within it.
Yeah, but how you are going to filter if you don't have indexes yet?
And where top 5 one? You sorted it and you can.
What?
What we can say? Why not take top 5? That's what. Why do you need to think?
How you can take
sorted it by count? Yeah. Now you have tuples of client ID to amount. So you take the top 5.
You want to make cake? But take is an action.
Take is an action, but
you will put all your data to the driver. You don't need it. How to cut your distributed collection of data only without putting the data to the driver?
Yes,
we need to do these operations on executor, right? That's why we are doing the zipping. We are creating auto increment. And okay.
So can you elaborate how the zip with index make it over the executor? Because it has to know the top 5 over all the executor, the index them all of them.
This is the one of them. Yeah. Zip with index. Why you shouldn't put like zip with index on the cluster? Because if you have the node, right? For example, you have tuples here. Client ID 1, then you have here 2, 5. When you are calling the zip index, that means you want to increment all over your collection. Spark will do it. Spark doesn't know how to like put you want to put here 1, 2, 3, 4, right?
Mm-hmm.
Spark can do it.
So you will make an action any case.
Spark will all the data to one node. It will be repartition one will be done for this operation. Zip with index, it's a making auto increment. You have distributed collection all over the class. You have several GVMs in work. You can't do auto increment all over the cluster. To do it, you need to put all the data to one node. Now,
so this is cheaper than actions and take.
It sounds like that. Yeah, I agree with them. But if you take only 5, it's not a big deal. So you
take 5. But
not a big difference.
No, I'm telling it's
no, we are taking 5 only after the sequencing.
No, I'm telling.
That's one point. If you need to do make IDs all over the cluster, there is another function, sequencing ID. Sequencing ID will produce unique ID, not incrementing, not one by one, but it will be unique.
But what is the cost from performance perspective?
Okay. Of course, it's a something. You need to move all the data from all over the cluster to one node. To make
the difference is that in XM you take all the data to the driver, and here you take it to one node.
Not the driver, the one executor.
Here. But in general, if I say take, use take. So we take all the data from the executor to the driver.
To the driver, yes.
So this is the difference between take and this agreement.
Take, it's an action. You're putting some data to the driver. We are going to use the API of Spark engine. That means that we want to apply all these methods all over on executors. So it's like different things. If action like put data to the driver, it's like when you are working on the cluster, you don't need to put all your data to one machine. This is the case because for our example, when we want to make like auto increment. But in general, GPU syntax will it's very bad for performance because you need to put all the data to one node. GPU unique ID is better. But it's not sequence, it won't sequence.
Other actions like sort by don't require to put
sort by is not an action. Sort by is not an action.
Not an action like logic.
No, sort by will be sort by. What do you mean? Yes.
Yeah.
So it's not an action.
Intolerant?
Of course. Why not? No, of course. Sorting by, looking by, it's like, of course, shuffle. What is the shuffle? That moving data from one node to another. For some operation, you will need to perform shuffling because if you want to group by, for example, you need to move data all over. So we again here we will have top 5 clients, so top 5 client ID, and to save this data to one file, I'm going to make 2 districts of the same type. The first district of cells and bytes will be there. I want to build like the general string will be like this string here. So what we are counting, and the list of values, and I want to make such results for every district. So here we're creating this collection bytes. How many bytes, cells, how many cells. We are making the same structure for top 5 client list. In the tuple will be top 5 client. First parameter is, and this list of all values of all top 5 clients is the second parameter. Let's run the example because the result. 1 minute. Recordings. Data. Producing the data, we are splitting the general file, and with delay, putting the new file to the target folder. Spark streaming is listening this folder, getting the new file, processing it, and the result is this is the checkpoint. This is the data. This is the state of Spark streaming process. It's like some kind of internal. And every second, you've got the file like this. How many cells bytes every second, and top five client list all over the Spark streaming process. Two words about more functions. So how now we know that we want to update the state all over the Spark streaming process. Okay, but what if you want to aggregate this data, for example, for the past 1 hour, for the past 2 hours? You can use the window functions. Spark streaming allows you to use aggregations by certain interval of time. So for these purposes, we can use the window functions. So in this stream, we have reduced by end window, for example. We can set up the window for 1 hour, and we can reduce the data on this interval of time. But 2 words about time intervals in Spark streaming. The main interval is batch interval. How often we are consuming data. The second interval, slide interval, and the window interval. For what interval of time we want to aggregate the data. What is the slide interval? Slide interval means how often we want to produce this window. This is the example. It's a batch interval every second, for example. Window interval, 3 seconds. We want to aggregate the data for 3 seconds. But we want to produce this window every 2 seconds. That means that 3 seconds we have new window, but next window we want to produce in 2 seconds. So it's like sliding step. It's like a sliding window, but we want to recalculate this window every slide interval. This is the slide interval. So we want, for example, by default, slide interval is equals to batch interval. That means if here slide interval is the same as batch interval, we have window like this. Here. But in this example, sliding interval is 2 seconds. So we will produce a recalculate window every 2 seconds. So thank you. 7 minutes more. Sorry for troubles.
Thank you.
I'm just
Okay.
I never knew you can. Right. Now I will. Yeah.